Hi, my dear students. Today we are going to discuss about the Rolle's theorem, the Rolle's theorem in calculus. For Rolle's theorem, it is given f of x should be a defined one and continuous. Defined one and continuous on a closed interval a comma b, and f dash of x should exist and it should be defined on the open interval a comma b. F of a should be is equal to f of b. If it is so, if all these three conditions are satisfied, then f dash of c is equal to 0. F dash of c is equal to 0. Okay, so the concept of this one is, consider a function, a symmetrical function from a to b, and this value is equal to this one. This is f of a value and this is here, and this is f of b value and this is here. So actually what will be this point, a comma f of a and b comma f of b, and this f of a is equal to f of b, both are same values. Then there should be some value, right? There should be some value c, there should be some value c in between this a and b, so that f dash of c become 0, right? C belongs to this open interval a comma b, and that should be the point. At this point the value becomes 0, right? F dash of c, that is, you will be getting a horizontal tangent. That's the idea of Rolle's theorem. That's the idea of Rolle's theorem actually. Let's discuss a problem now and consider a problem for that, right? Verify Rolle's theorem for the function f of x is equal to x power 2 minus 2x minus 15. X power 2 minus 2x minus 15. That is, f of x is equal to x power 2 minus 2x minus 15 minus 3 comma 5. Let's go ahead with this function. Now consider whether f of x is defined in this interval. Actually, it's a polynomial. Whatever the value you are giving from this interval, you will be getting some f of x value, that is y value, and hence f of x is defined and continuous. Defined and continuous in your interval minus 3 comma 5. And the second one, what about f dash of x? That f dash of x, it is 2x minus 2. That f of x is equal to 2x minus 2 is also defined and continuous in minus 3 comma 5 in the open interval. The 2x minus 5 is a linear function, so whatever the value you are giving from minus 3 to 5, you will be getting some answer. And the third one, we have to find f of minus 3, that is f of a. Okay, this is a and this is b, which is f of a. We have to find f of a is equal to, it is minus 3 power 2 minus 2 into minus 3 minus 15, and hence it is 9 plus 6 minus 15 is equal to 0. Find the next value, f of 5, that is f of b. This is the b value, right? Which is equal to, it is 5, right? So it is 5 power 2 minus 2 into 5 minus 15. So it is 25 minus 10 minus 15, which is equal to 0. And hence f of minus 3 is equal to f of 5. So f of a is equal to f of b. That condition has been satisfied. So by Rolle's theorem, there exists some point c belongs to our interval a comma b, that is minus 3 comma 5, so that f dash of c is equal to 0. So what is f dash of c? f dash of c is equal to 2c minus 2, but this value should be is equal to 0. So it is 2c is equal to 2 and the c is equal to 1. Now let us check whether this c is equal to 1 belongs to the given interval. The given interval is, what is that, minus 3 comma 5. Is it? Yes. Consider your line. It is minus 3. Here it will be 0 and here it will be 5. C is equal to 1, right? So 1 will be here, this place, 1. So it is in our interval minus 3 comma 5, and hence the Rolle's theorem has been verified. We are getting a value c is equal to 1, which is between minus 3 comma 5, and that value f dash of c become 0. This is what from Rolle's. This is one of the counter examples for Rolle's theorem, and there are few functions in which we can prove the Rolle's theorem cannot be verified. For example, consider another one. F of x is equal to 1 by x in the interval minus 1 to plus 1. Immediately you can say the first condition itself has not been satisfied. Why? Because f of x is not defined at x is equal to 0, and hence Rolle's theorem cannot be verified. Right? Cannot be verified. And you can go for few more also. F of x is equal to some x divided by x minus 3 in the interval. Which interval? Maybe take something 0 comma 4. This function we cannot verify the Rolle's theorem for this function at x is equal to 3. That is x minus 3 equal to 0, x is equal to 3. X is equal to 3 is in between, right? 0 to 3 is in between. But if you put x is equal to 3, this f of x become, what is the value of f of x at x is equal to 3? So it is 3 divided by 3 minus 3, right? 3 divided by 0, which become undeterminate. That is not defined, and hence we cannot find the Rolle's theorem for this function. And and it is especially for the symmetric function for which you will be getting the f of a is equal to f of b, and sometimes you have to be careful with this one also, the last condition. And you may go for few more problems to go for this. For example, f of x is equal to square root of x. F of x is equal to square root of x minus 2 with some specified interval, right? For example, open interval 0 comma 2 and this interval 0 comma 5, something like that. This is just about Rolle's theorem. You can go for a few more to explore yourself. Meet you on some other lecture. Till then, see you and bye bye.